Hey, good morning, friends, neighbors, folks poking their head over the fence. This morning's little conversation is about Fukushima Daiichi and the first week of response to the accident. This is a bit of a different take. We know that three reactors blew up over a period of weeks and months. We know that fuel pools melted, burned, and bubbled for periods of weeks and months. Each one of them had emissions. So the world is in a catastrophe mode, and I do mean the world. The world was paying attention to Fukushima. So what do? We send the most sophisticated piece of military equipment we've got on the planet, arguably one of them anyway, is an aircraft carrier. Aircraft carrier has a dozen, at least, support ships that it protect it from everything from missiles to aircraft, supply ships, fuel ships, ammunition ships, parts ships. So there is a fleet that travels with every aircraft carrier. These aircraft carriers are supposed to have been designed for nuclear warfare, right? We pay a lot of money for this stuff. Don't kid yourself. Tons of money put into it. So the whatever fleet number this was with an aircraft carrier went into Fukushima space and they got hit. They got hit big time. Now, there's a number of reasons they should have been able to track this stuff. Anything from radar systems to instrumentation sets that should have been turned on and should have been activated. This would have been a perfect test for a military response to a nuclear incident and all the mechanisms that are supposed to happen. So what happened? Something failed big time out there because that naval ship with the most sophisticated instrumentation that you can probably think of is sitting there and got hit by just waves, air waves of pollution. So what does this matter? Well, in past life I installed uh, instrumentation, and one of them went to an Air Force base that examines jet aircraft engines. So they're doing failure mode engineering analysis on jet aircraft, and they're looking for trace elements in the metals for contamination, because a lot of metals will cross-contaminate, and the isotopes that are created from nuclear fallout destroy metals. There's things like gallium and a few other contaminants that will actually destroy the crystalline lattice of metalwork, and that's what happens. You can go find lots of videos on this. Thiokol and other places show some of these things acting. So from that, besides all the sailors that were contaminated, the Air Force or the Navy was forced to throw away multiple aircraft and pieces of aircraft. And the reason for this was they flew through plumes of radioactive materials that will destroy the airframes of those helicopters. It will absolutely eat and crystallize them, and it could happen within a week or within a month or within a year of exposure to things like gallium and some other metals that cross-contaminate metals. Now, once they're contaminated, they're also trash. They shouldn't be sent to recycling or anywhere else because the contamination can't be removed. So that is a tough one. That was one of the costs of Fukushima. I know that we replaced hardware off an aircraft carrier because it was exposed to radiation. There are records of that. I don't know how extensive the records are, what the total cost to us was, but we also lost a lesson. How that ship was contaminated, what happened to the sailors, and what is happening to the sailors is still ongoing. Someone knows some degree about it, or they're looking for it, because that's what you have to do with this stuff. Once a metal is contaminated with this stuff, it can take weeks, months, or years for the damage to the structures to be done, and they just fall apart. So here's another little piece of Fukushima costs. Besides the lives that were put at risk with our sailors, the equipment cost just for that aircraft carrier's dispatch alone and the follies around it and the cleanup around it taught us something for the next time. I'm not sure what, but This is the nuclear world. This is the details in nuclear fallout that just get lost in these conversations for some of the noise about the physics and the way we measure. And the challenge is we do measure. We know how to measure. It is very important because one of the things we have to look for is delta, change over time. This is an important factor. It tells us what we're doing to ourselves when it's so subtle we can't see it in our normal day-to-day lives. But over years and months of accumulation, it has health impacts, it has environmental impacts, and some of those can be good. But we need to know. We need to not do the bad. That's life. That's learning. That's what humans are about. Send money for a haircut.